So mathematical induction is the important question in pure maths paper. That's the first question in pure maths. Shuddha ganiti palani prashne should this induction problem. The same as applied maths, first question is what? Collisions of impact. Impact bodies or spheres collide. That's the 25 marks in applied maths. Elastic collisions. And pure maths paper first question past many 10 years or nearby that mathematical induction 25 marks, the same as 2020. I'll show all the questions. I send all that tudes. I think you can connect to a printer. You can take a print out or any mode. Okay, so you can write that heading mathematical induction. Mathematical induction or method of mathematical induction. So actually that's the grade 13. There's some here 2022 students available, no harm, because it's a new chapter, completely new. There's nothing to learn any other form earlier, trigonometry or any quadratic equation functions. Without that you can go ahead with separate chapter induction. No problem for the juniors or seniors, right? Okay, so you know these there are several proofs in mathematics. Several proofs that one we called geometrical proofs. You learn all-level maths so far. Geometrical proofs. Another one we called contradiction proof. That's important in primary basic maths. We called one example: square root 2 is an irrational number. Proof is square root 2 is an irrational number. That's using the contradiction proof. That means object the statement and we continue the process, but later on we face you can't go ahead, you can't go to complete the answer. Then we called no shape, we agree with you. That's called contradiction idea. Okay. Anyhow, our problems comes always with mathematical induction. That's very useful things, mathematical induction pattern on the big question pure maths paper, right? Okay, then what do you mean there induction? There are some steps we have to show. Mathematical induction we are working for, or we are proving for any problems involving numbers n, positive integer n, or statements or theorems or any conclusions, any scientific formats, but should be n there. Number of sides of a quadrilateral polygons, number of values in a series of any number divisible by any form. That always should become with the positive number n. N can be 100, 1000 or infinity, whatever, right? So we have to prove for that such a statement. There are 3 steps proving method. Sometimes you already learn in somewhere in your teacher. So recollect with me. Very first we show the given statement true for n equal 1. True for n equal 1 or any n values. For any n values, we have to show that any means smallest n value. N equal 1 or smallest possibilities the value it can take. We have to prove that's true. Next, there's an assumption. There's an assumption that's called n equal p. N equal p, or sometimes the teacher says n equal k. We prove the statement is true for n equal k assumption. We guessing that, we call assumption, right? We assume that n equal k, the statement is true or hold. From that we have to go that n equal k plus 1. So that is the given data or given statement true for n equal k plus 1. Then if you go this order, I'll show the problems. The statement true for everything. It's like a Dominious card pack. If you that means if you fold one card, fold is all continuously fold together over that. So if n is 1 true, n is 2 true, n is 3 true, and so on For every integer values, this is true. That's the meaning of an induction method, right? So we'll write something, right? Write this note. The heading mathematical induction. Write this. Mathematical induction. Mathematical induction is a mathematical proof technique. Is a mathematical proof technique. Is a mathematical proof technique. Next para. It is essentially used to prove. It is essentially used to prove that a statement involving positive natural numbers n, positive natural number n, small n, positive natural number n. So I said that the idea of these given theorems or involving any format, right, should be like that. Right, next para. Proof by induction. Proof by induction. Proof by induction consists of 3 steps. Consists of 3 steps. Proof by induction consists of 3 steps. Right, first point, first part, first point or first step. Prove the statement. Prove the statement. Prove the statement. True for. Prove the statement true for n equal 1. Okay, the problem I'll show. I target to work block problem with you today. First point. Prove the statement true for n equal 1. But 99% we have n equal 1. But rarely some problems available the n equal 2, n equal 3. So within bracket write this, or the least value of positive n, or the least value of positive n. This is the first point, right? You have to prove in the order. Right, second point. Take an assumption. Take an assumption that the given statement. Take an assumption that the given statement is true for n equal p. 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 Within bracket show where p is an integer. P is a positive integer. Where p is a positive, p sometimes k, they say k or p, right? A new letter, right? P is an integer. Hence, show other point, other condition or the case. Show that it must true. Show that it must true for n equal p plus 1. 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 So these are the 3 cases, right? right? Finally, once you show this pattern in the marking scheme, you will give finally the brief answer. Therefore, the given is true for every integers. Therefore, the given statement or the equation true for all these positive integer statements, right? So write these are the para. If any statements proved of the above manner, then the statement holds for every natural number n. Holds for every natural number n. So here I said something about the not induction, but these are useless. You need brief problems, how to work, how to start a question using induction. Mathematics means problem. You have to work very 100 problems in each lesson. Then become easily forget high pass in all your exams. Okay, so you have treat, I think I did a lot of questions, 84, 83 problems, right? I'll show one by one, see, identify how to work this induction method, right? So first question there, 1 plus, here, 1 plus 2 plus 3 plus 4 up to n numbers, 1 plus 2 plus 3 plus 4 up to n numbers. The answer is n by 2 n plus 1. So dear student, this is very important formula, general formula in mathematics. Actually all over mathematics, you learn in arithmetic series. Sum of n numbers, the formula, n by 2 a plus l, n by 2 a plus l. The same thing here, 1 plus 2 plus 3 plus 4 up to any 100 numbers. What the summation? 100 by 2, 100 plus 1. 50 summation numbers, 50 by 2 into 51, 50 plus 1, right? Therefore, here n by 2 n plus 1, it's a statement here, it's a formula. It's a series question. In all the past papers or future papers, the induction problems comes 2 methods, 2 cases, 2 types. One is series pattern, one is divisibility problem. Everything there, future problem, past problems, everything there in the tute. Okay, so I will show another pattern. Some newcomers here, that juniors. We can write as a series pattern. There's a general term here, right? What is general term? If I say UR, that is R. General term is R. In O-level maths, you told Tn equal A plus n minus 1, like that pattern. Here R is the general pattern, general term. If R is 1, first term, U1, U2, R is 2, U3, third number. So here this summation, there's another format of writing. Sigma. Sigma means addition, right? Sigma UR, R equal 1 to n. Sigma UR, R equal 1 to n. This is equal to n by 2 n plus 1, right? The same, the last I work last week exam pure maths, the similar fashion they put sigma type, right? So every series pattern we can write the sigma notation. Yes, welcome Rashindu. Yes, sir. Every series problem we can convert to sigma format, sigma UR, right? Sigma UR. Sigma UR, R equal 1 to n. This, so nothing difficulty, nothing a new thing. If you write R for 1, U1, there is 1 first term. Put R for 2, U2, second term, third term. Adding all the answer that. So I shown 2 methods. Straightly series pattern or that format, right? Okay. There are already 54 that's registered, but this time band only few, 16 members I think participate this morning hours. Others come the evening, tomorrow morning somebody say the 4. So busy, the students are very busy than the students due to these online sessions. Okay. Now come to the first question, how to prove this by induction method, right? So very first point, if n equal 1, if n equal 1, right, we show the statement is true for n equal 1. I gave my note, right? See, if n equal 1, what is left hand side? LHS. What do you mean n equal 1? First term, one term, right? So left hand is 1, LH is 1. See, RHS, right hand side, what is n equal 1 mean? First term, put n for 1, put n for 1, right? So 1 over 2, 1 plus 1, so no doubt that is 1. Therefore left hand side 1, right hand side 1 equal, right? Therefore we called LHS equal to RHS, right? That is n for 1 true. N for 1 is true. That's the method. First point, induction principles, show if n equal 1, it's true. If it's failure, you can't go ahead. Now second point, but that second I said my note, assumption. You assume that the given statement is true for n equal p. Okay. So assume that, right, is not, assume that given statement is true for n equal p. Assume that the given statement is true for n equal p. That is copywriting. That is copyright. Put n for p, that's all. Where is n? Say k or p, right? So that is what? That is 1 plus 2 plus 3 plus 4 up to n. But the answer p by 2, p plus 1, right? P by 2, p plus 1. That is second statement of proving induction method. Assume that n equal p, given statement is true. Okay, this is the sum of the first integer answer. Not only for this lesson, you need this in the series, the big problem, essay problem series. This formula required. Some applied maths, some collision problems also you need this formula. Okay, p by 2, p plus 1. Okay, next point, if n equal p. So if I correct once again how to prove the induction method, show n equal 1 true. Next, assume for n equal p, it's true. From that you have to go n equal p plus 1, n equal p plus 1. What do you mean n equal p plus 1? What do you mean? For example, 100 numbers. Now find 101 that number up to that. If it's 10 numbers, find the sum up to 11 numbers. If it's up to 20 numbers, find the sum for 21. Anit padet liyanda one. See, everything is p numbers and the other one is p plus 1. Okay. So see that form. That's the main part of the question, right? That's the main part of the problem. Once you shown up n equal p, what is p plus 1 next term? See, therefore 1 plus 2 plus 3 plus up to p and next one p plus 1, right? P plus 1. Okay, 1 2 3 4 up to p, the other one p plus 1. Okay, see, I give some technique how to find this method. So when you go to the n equal p plus 1, before answering the problem, before get the answer, you decide what should be. මොනවාද උත්තරෙන්ට ඕනේ හදන්න කලින් හදාගමු. So there is, see here, if you put n for p plus 1, if you put n for p plus 1, බලන්න what the answer, n for p plus 1, like this, n for p plus 1. That means what? P plus 1 by 2, p plus 2, ne? P plus 2. So roughly I am showing this. So you should get this answer when you start using the n equal p plus 1 method procedure, you should get this answer, right? So that's the method. Before working, you find roughly what should be the final statement, final solution, right? So therefore, see the method. First question is, see this, 1 plus 2 plus 3 plus up to p. So always when you use this assumption, hence go to the other part, your assumption answer sufficient. That it should be implemented here. Without that, you can't go, right? So see that, you know, up to the p summation, you know the answer, p by 2, p plus 1, okay, p by 2, p plus 1. Plus additionally now we have p plus 1, that's all. Here after your algebraic O-level mathematics, simplify, get it. Can I take the half out? Take the half out. Can I take the p plus 1 out? So what the rest? So here p, here 2 is it? Here 2, ne? Here 2. Here 2. See what should be the answer, that is there. But when we writing final step, we won't show straight like that. We are copying by substitute knowledge. What you apply for n equal p plus 1, that we will show that, see that, half, put n for p plus 1, a bar, a bracket, that also bracket, right? See other one, p plus 2, can I write? P plus 1 plus 1. Okay, so for n equal p plus 1 pattern, p plus 1 by 2, p plus 1 plus 1. Complete p plus 2. So the original answer, if you apply n for p plus 1, what? That is this. So therefore n equal 1 true. We assume that n equal p true. Hence we complete p plus 1 is true. Is the method. Any problem, send a message, or you muted on your microphone, tell. Simple first question. So many juniors available. No problems with 13 lesson, no matter. But simple question, separate lesson, this is induction method. First problem, the pure maths paper. Okay, then finally you have to give a statement. Then write below. Therefore, after showing this, you have to give the final answer. Therefore, the given statement. Therefore, the given statement is true for every integer n, every positive integer n. Therefore, the given statement is true for every positive integer n, every positive integer n. So don't forget that there's a marking scheme, final solution. 25 marks, a simple problem. You can minimize the time. I take long explanations. You can minimize the work. Work is that, but you can, time is quick, you can work here after. Okay, see next question, second problem. This is the theory part, not only a problem but also theoretical question. How to find the sum of the first natural numbers, n by 2, n plus 1, right? See second question, problem number 2. 1 square plus 2 square plus 3 square plus 4 square up to n square, no? That is what? Sum of the first square numbers. Sum of the first square numbers. 1 square, 2 square, 3 square, like any 100 square or 50 square summation. Here also keep in mind this formula is n by 6, n plus 1, 2, n plus 1, right? N by 6, n plus 1, 2n plus 1, right? 2n plus 1. N by 6, n plus 1, 2n plus 1. Very useful formula, not only for induction but also your essay problem series question, the big problem of binomial theorem with the series and the interesting easy problem in your exams. Okay, I'll show again this the method of induction. They ask in an essay paper also by using the induction method or otherwise. Otherwise means series method. Yeah, you can use the series formula also to prove this. Today my target to complete some few about the induction pattern. So dear, follow that pattern, the steps how to proceed the induction method. Very first point, if n equal 1, show the statement is true for n equal 1, right? First number, n is 1 means first number. So what is that? LHS, left hand side, 1 square, no doubt that is 1. Left hand side, if n is 1, first number, right? But the next point, right hand side, RHS. Right hand side, here put n for 1, 1 over 6, 1 plus 1, put n for 1, then what, 2 plus 1. So no doubt you know these 3 here, 2, 6 is cancel, right? Therefore 1. Okay. Within 40 minutes it will disconnect. I think I'll reconnect you, right? One period 40 minutes, the Zoom view available for first 40 minutes. We'll rejoin that, right? So therefore you can say, therefore LHS equal to RHS. Left hand side equal to right hand side. Both side equal. N is 1 true. Or you can write a word below. Therefore statement true for n equal 1. Therefore statement true for n equal 1, right? The second step, n should be replaced by p. N should be substitute by p. Yes, n for p. That's the method. Substitute by p, right? Continue. You can see some other questions here, right? Okay. Now we go assumption, right? Next, right? Assume that statement true for p. Assume that the given statement true for n equal p. Assume that the given statement true for n equal p. Okay. So write that. That is copywriting. Write everything. Where is n? Say p. So 1 square plus 2 square plus 3 square and up to p square. The other side put n for p. P by 6. N by 6, n plus 1, 2n plus 1. P by 6, that is p plus 1, 2p plus 1. Okay, that is straightly assumption, copyright straightly. Where is n? Replace n for p or substitute for n for p, that's all. Okay, next the main part. That's the main part. If n equal, next term, p plus 1. Okay. If n equal p plus 1, if n equal p plus 1, follow that method. As I mentioned earlier, see n equal p plus 1. So whenever you use to the n equal p plus 1, you need the assumption answer. From that, write the other new term, this other term. Therefore that 1 square plus 2 square plus 3 square and up to p square. Okay, and the next term p plus 1. If up to 100 mean 100th one. Up to 7 mean 8th term, right? So that is p plus 1 square, right? P p plus 1 square. So as I mentioned earlier, you can stop this and see what the answer should be. Uttare monawada entone. After doing the summation, answer should be what? So what if you apply n4p plus 1, n4p plus 1 over 6, n4p plus 1, 1p plus 2 into what you put 2p plus 3. Check that. P plus 1 by 6, p plus 2, 2p plus 3. I am showing this, you can't see that my long this board. Okay, anyhow. So before finishing, before get that answer, you can collect what should be. Okay. So where I use the last statement or last case of proving, we should take the assumption answer 1 square, 2 square, 3 square up to p square. You have the answer already. It's equal to what? P by 6, p plus 1, 2p plus 1, right? Always that help. Easily you can apply that. And there's a new part called p plus 1 complete square. P plus 1 completely square, right? So the summation is okay, the new term. Now simplify this as possibility. You know answer. You know the answer what should be. Okay. So therefore, it's equal. What is that? Think easy method. Think easy method. P plus 1. Here also P plus 1 available, right? Take out. Take the P plus 1. Factorize. And below 6. Take the 6 out. That is P plus 1 over 6, right? I take these things out. So what the rest part inside the bracket, p plus 1 by 6 out. Therefore p into 2p plus 1 into 2p plus 1 plus a 6 and p plus 1. Okay. Take the p plus 1 out, then p there, 2p plus 1 available into 6 into that, okay? Therefore, p plus 1 by 6, you can get a quadratic expression inside the bracket, right? That is 2p square, here 1p, 6p, 7p, okay, plus 6, right? So finally, or before that, p plus 1 by 6. So you factor all your mathematics. You can factorize, I think, what 12, 4 and 3. You can factorize 2p plus 3 and mother p plus 2. Is it 2p square, 4p, 3p? Yes, so factorize, ne? 2p plus 3, one factor. The other one p plus 2. This is the final answer. If you put n4 p plus 1, apply n4 p plus 1, p plus 1 by 6. Put n4 p plus 1, p plus 1 plus 1. That is p plus 2. Ne? Next put n4 p plus 1, 2 into p plus 1 plus 1. That is there. So everything is okay. But in marking scheme, finally, you have to rearrange or separately show that we obtain by apply n4 p plus 1 here. So the best answer finally, p plus 1 show like a bar. The bracket, it's a bracket, right? Bar called like a bracket form over 6. That is one thing. Other one, p plus 1 plus 1. Other one, 2 into p plus 1 plus 1, okay? Like that show, you can complete that method, right? So I hope you understood this second question using induction. These are not only question but also theoretical part. Don't forget your future knowledge of pure maths series question. This is what? Sum of the square numbers. Sum of the square numbers. 1 square plus 2 square plus 3 square plus 4 square, like any square number. general formula, n by 6, n plus 1, 2n plus 1. Okay, this is the method, right? So then finally you have to give answer. If you shown n equal 1 true, if you assume n equal p, hence you got it the n equal p plus 1, therefore give the answer. Therefore the given statement is true for every integer n, positive integer. Therefore the given statement is true for every integer n, every integer n, every integer n. Therefore the given statement is true for every integer n. Okay, if you juniors, if you problem the first question, I think this is okay, something like a 5 or 10% okay now. After working the third problem, I hope you can teach me. We'll see third question now. Then also theory part, 1 plus 2 plus 3 the answer n square over 4